How do you use arcsine, arccosine, or arctangent to calculate acute angles in a right triangle? If you know the lengths of two of the sides in a right triangle, you can use arcsine, arccosine, or arctangent to calculate the size of an acute angle. Let's consider some examples of how this works. Say you have a right triangle where A is a right angle, AC has length 5, and BC equals 10. You want to find the size of angle B. You have the length of the opposite side, O, and the hypotenuse, H. SOHCAHTOA tells you that you need the sine formula. Sine of angle B equals AC over BC. To solve for angle B, you use arcsine on both sides of the equation and get that angle B equals arcsine of AC over BC. AC equals 5 and BC is 10, which gives you arcsine of 0.5. Okay, so to find the size of the angle, you need to calculate arcsine of 0.5. This is where your calculator can come in handy. Inputting arcsine of 0.5 into your calculator gives you 30 degrees, which means angle B is 30 degrees. You've found the unknown angle. An interesting question is, what did people do before they had calculators? Well, they had huge books containing tables of the values of sine, cosine, and tangent of many angles, and these weren't always easily accessible to anyone. It's amazing that nowadays, almost anyone can find these values with a device in their pocket. Let's look at a different example. Given a triangle DEF, where E is a right angle, DE has the length of 7 and DF equals 9. You want to find the size of angle D. So, here DE is the adjacent side, A, and DF is the hypotenuse, H. Using SOHCAHTOA, you find that you need the cosine formula. Cosine of angle D equals DE over DF. Applying arccosine to both sides of the equation, you get angle D equals arccosine of DE over DF. Let's plug in the known values. DE is 7 and DF is 9. To find the size of the angle, you input arccosine of 7 over 9 into your calculator and get approximately 38.9 degrees when rounded to one decimal place. Now, let's take a look at one final example. Say you have a triangle PQR, where P is a right angle, PQ has the length 4 and PR equals 2. You want to find the size of angle Q. Here, PR is the opposite of O, and PQ is the adjacent side, A. Looking at SOHCAHTOA, the tangent formula seems like the right one to use. Tangent of angle Q equals PR over PQ. So, to solve for angle Q, you apply arctangent to both sides of the equation. Angle Q equals arctangent of PR over PQ. Plugging in PR is 2, and PQ equals 4. You have 2 over 4, or 0.5. Inputting arctangent of 0.5 into your calculator, you get approximately 26.6 degrees when rounded to one decimal place. There you go. Angle Q is about 26.6 degrees. If you know the lengths of two sides in a right triangle, you can use arc.sine, arccosine, or arctangent to calculate the size of the acute angles.